Excellent, thank you very much for that. I'm just going to do the modern thing when you're at a big event, which is to take a selfie. If everyone could just... There we go. Very good, right. On to something more relevant and interesting. So, my name's Trevor Bond. I'm a geomorphology technical specialist at the Environment Agency. I cover the 3 counties of Essex, Norfolk and Suffolk, and I'm based out of the Ipswich office today. I'm going to be talking to you principally about the challenges of working in lowland rivers when it comes to doing river restoration. And we focused a lot today already on the kind of lentic ecosystems, the relatively kind of slow or no flow systems, and now we're going to move it on to rivers, which is my passion. So just a quick outline about what I'm going to talk to you today. An introduction to geomorphology. So for me, I think it's really important to know where our landscape has come from in understanding about the natural world, and I'm going to explain to you how geomorphology keys into that. I'm going to then talk about specifically the geomorphology of Suffolk, since this is the Suffolk Naturalists Society conference, seems apt. Then we're going to discuss briefly the links between geomorphology and ecology. I know we'll have many ecologists in the room, so I apologise now if some of what I say is not strictly accurate. My background's in geomorphology, but I think it's important that we make the link. And then we're going to discuss the challenges of working in low-energy rivers. Sometimes East Anglia isn't considered very interesting in terms of the geomorphology, and that's because there isn't a lot of energy around. There's no gradient, and we're going to discuss the kind of issues that raises when you're trying to restore rivers. And then we're going to look at some proven river restoration techniques. I know we've got lots of NGOs in the hall today who are actively involved in river restoration. There might be people around who don't know much about it and want to know more. We're going to look at some of the methods that you can use to improve our degraded rivers. And then lastly, we're going to discuss the examples that the Environment Agency have been involved in over the last couple of years across Suffolk, and we may also have time to touch upon Essex and Norfolk as well, just to show you some of the work that we've been doing in partnership with others. And then some closing remarks, some take-home messages that I want you to remember. So just to start, an introduction to geomorphology. Pretty simple, comes from Greek. You've got geo, which is earth. You've got morph, which is form or shape, and then you've got ology, which is study. Really simple, yeah? So we're talking about the study of the earth and its form. And then you've got David Sear and Malcolm Newson, who gave this definition for fluvial geomorphology. By fluvial geomorphology, we mean moving water geomorphology, i.e. rivers. And David Sear and Malcolm Newson said that fluvial geomorphology is the study of sediment sources, flux and storage within the river catchment, and blah, 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 blah. It's quite a technical definition, yeah? But what you need to know is that it's about the way that rivers work. When we talk about fluvial geomorphology, it's about the way their form and their function. That's what we're looking at. But it's not just fluvial. I know that we've got Geo Suffolk here today, and they might be interested in some of what I'm going to touch upon. Geomorphology is also to do with glaciers. It's really relevant to East Anglia in this part of the world. As we'll come to see, many of the glaciations over the Quaternary period, the last 2.6 million years, have been named after locations within Essex, Norfolk and Suffolk. So glaciology is really important. The east coast, particularly Essex, Suffolk and Norfolk, are amazingly unique for some of their estuarine and coastal features. The geomorphology you see there is truly exceptional. I think of things like the Bar estuary up in the Old Anor, which is the only example of that type of estuary within the UK. And you'll know that many of our estuaries and coasts are designated because of their unique ecology, the Triple SI, Sachs and Ramsar sites and things like that. So coastal geomorphology is really important. We're not going to discuss it today, but that could fill a whole other talk. And then aeolian geomorphology, which sounds a bit weird, but it just means stuff that's blown around by the wind. And if you look at the fertility of the soils in East Anglia in particular, the fact that they are so good for farming, a lot of that is a function of wind-blown sediment that's come over from kind of continental Eurasia. And that's what we're talking about when we talk about aeolian geomorphology. Again, not something we're going to touch upon today, but just to give you a bit of background. It's not just rivers. And then this is me kind of bigging myself up. If you're a geomorphologist nowadays, you can't just be some geeky person who's sitting in a lab and playing around with sediment and sifting it and counting the size and stuff. You need to have a fairly good understanding of hydrology and ecology as well. And what I want to do in this presentation is really bring all of that together so that it doesn't just seem like some kind of abstract thing. What is geomorphology? We're going to look at the academic side, and then we're going to bring it together, and we're going to show you some applied examples from across the county. So that's an introduction to geomorphology. East Anglia, a geomorphology hotspot, one of the best places in the country to be if you're a geomorphologist. Now this is a table of all of the glaciations that have occurred over the last kind of 1.3 million years, which is a lot. Now you'll notice all the ones that are highlighted in yellow. They're all named after locations in East Anglia. So the Ipswichian is named after Ipswich, obviously. The Hoxnean is named after the village of Hoxton. You've got the Anglian, which is obviously the Anglia region. The Cromerian, which is Cromer, up in North Norfolk on the coast. And similarly for the Beestonian and the Pastonian, both those are named after villages on the North Norfolk coast. So the reason all of these names exist and are given for these particular glaciations is because evidence has been found in these locations for those glaciations. So the Ipswichian and the evidence for that, for example, was found in Ipswich and so on and so forth. Just to give you an idea, small map here showing that we've got evidence from different parts of the county and outside of the county into Norfolk, and also even down into Essex here, pretty much London, which is the extent of the Anglian glaciation, which is the largest glaciation that ever happened. And that was approximately kind of 300,000 years ago. And many of the sediments that we have all across our country and within our rivers, within the county of Suffolk in particular, actually came from glaciations not that happened 10,000 years ago or 20,000 years ago, but much, much further in time. Okay, so we're not talking about the Devensian, which was the last ice age, but many, many iterations of ice age before that. It's just a quick history of glaciation, some maps here to show you. You've got kind of the British Isles excluding Ireland, shown by the blue line there. And to give you an idea of where the last glaciation came to, this isn't strictly true, this was the Wolstonian Ice Age, but approximately that blue line. Okay, so it didn't really touch much of Suffolk, a little bit of Norfolk, and that was pretty much it. But the Anglian glaciation, which is the biggest ever recorded, really came down. That's where the majority of our gravels come from that occur in our rivers, and it's the one that moulded the landscape to what it most resembles today. And just to give you an idea of the location of Ipswich and Norwich there. So even Ipswich would have been under ice about 300,000 years ago, which is something to bear in mind. Just a little bit about fluvial geomorphology. I know we're jumping along and around a bit, but all that glaciation stuff has had quite a big influence on what we see in the landscape today. And across Essex, Norfolk and Suffolk, which is the area that I cover, there's a real mixed geomorphology and a really mixed geology. To give you an idea, Norfolk, most of you will probably know, dominated by chalk for the most part, particularly in the kind of northeast and the north. And that has a long history of glaciation. Suffolk and Essex less so. The glaciers kind of came down a little bit, but not all the way, and they have periglacial conditions and are dominated by clay and gravels. And the relevance is it significantly affects the hydrology, which we will come on to discuss. So yeah, just to give you an idea, this map here, the blue area shows the underlying chalk that we have across the kind of three counties, and you can see you get little blocks in Suffolk, and it's mostly Norfolk where you get the Norfolk chalk streams. You've got the River Stiffkey, the River Nar up there, and some other bits and bobs. There are quite a few rivers that aren't designated as chalk streams in our kind of area that certainly could be. And by chalk stream, we mean something that is dominated by groundwater. So maybe 75% of the water in the river will come from groundwater sources, and they have very good water quality. So yeah, all of our river systems are relics of former processes. I'll come on to a little bit about what we've done as people to affect our rivers, but initially it's good to understand what what the natural world has created for us. And channels have evolved over the Holocenes. The Holocene is the last 10,000 years. Some people call it the Anthropocene because of the effect that people are having upon the global climate. And to give you an idea about how rivers have changed over those last 10,000 years, firstly, get the idea of a straight river out of your mind. There's no such natural thing. If it's straight, then people have done it, pretty much. Okay? Our rivers used to be multi-channeled, they used to be braided, they used to be high energy, they used to be full of gravel, they used to be dynamic and changing. And then over the course of the last 10,000 years, as the energy from deglaciation kind of evaporated, and there wasn't as much energy around and not as much sediment, our channels slowly became a little bit more single thread, not as interesting, you could say, not as dynamic. Okay, and that's where the kind of archetypal view of a meandering channel comes from. Okay, a meandering channel is indicative of a landscape that's had many, many thousands of years to settle down after glaciation. So our rivers once used to be quite wild, and even our modern rivers are very different because of everything that's happened before. So you'll probably know that Essex is relatively urban, a lot of precipitation domination there, by which I mean it responds quickly to rainfall. If anyone lives in Essex and experiences that, you can see that. And to give you an idea, this is a hydrograph at the top. Okay, so all we've got here on the horizontal axis is time, and then on the vertical axis you've got rainfall, which is the big orange blob, and then the red line is the water level in a river. Okay, we've had about 10 millimeters of rain in about 2 hours in this example. It's nothing, tiny amount of rain, but the river has responded instantaneously, and that's what you typically get with an Essex river, really fast responding. In Norfolk, it's entirely the opposite. Okay, you can have 3 mil of rain in 15 minutes, you can have something really intense, and the hydrograph, the red line, the water level, doesn't change at all. Okay, and that's very indicative of these chalk streams. They're dominated by groundwater, they don't respond quickly to rainfall events. And then Suffolk, which is kind of halfway in between, and this is an example from the River Box at Boxford. You can see you've got the rainfall event, the kind of block of orange there, and then the river responds in quite a leisurely way. It's not too fast. It's like, yeah, hey, bit of rain, not that bothered. And you get this relatively long lag time between the rainfall hitting and the river reaching its peak level. There are some responsive rivers within Suffolk, so things like the Rattlesden Watercourse, the top of the River Stour, the Stour Brook, very responsive. But generally speaking, Suffolk's kind of a halfway house. And that seriously affects not only the geomorphology, but also the resultant ecology of those rivers. And as a general rule, you would probably say that many of the chalk streams in Norfolk are perhaps more ecologically diverse, more ecologically valuable than some of the rivers you might find in Suffolk. This may not be the place to say that, but that's just the truth, I'm sorry. So geomorphology and Constable, there's an online blog that I used to write as part of called the River Management blog. And my colleague Simon Dixon, who now works at the University of Birmingham, did a little piece on what paintings that John Constable did tell us about geomorphology. Anyone know this painting? It's got writing on it. The Hainway, right? Okay. So even in the 1800s, 1700s maybe even as well, we already had physical modification of rivers by people. And that has been captured in art, it's been captured in records. I mean, you can go back to the Doomsday Book, you know, nearly 1,000 years ago, saying that there are mill structures on our rivers. And John Constable actually captured a lot of how our rivers were modified and have been modified historically. So you've got a mill structure there, you've got people getting into the river causing bank poaching. The river has obviously been widened, entirely unnatural, even that far down the system. And actually, there's not a lot of riparian tree cover as well, which is entirely unnatural. In other photographs, you can see that already the watercourse is mainly for navigation. You haven't got anything on the floodplains. There's no real floristic diversity there. Again, the trees are being taken out. People are building bridges. You know, 200, 300 years ago, these are already heavily modified water bodies, and this is the River Stour. I mean, the River Stour is probably one of the most heavily modified water bodies in the country. It's truly stunning. And again, another example from the Stour. There's no woody debris in that channel, no woody material at all. There's no riparian tree cover. The river is actually perched above its floodplain, which you can just slightly see in this image. And so there's no floodplain connectivity. This is not a naturally working ecosystem. And when we talk about river restoration, it's this kind of thing that we're trying to undo. Hundreds of years of modification. This is a bit more like it. We've got a heavily incised channel. You've got bits of wood falling into the river. You can see the erosive processes, particularly on the right as you look. And there's plenty of shade in there, which is good in moderation. So I've put here nick point recession, which is this idea where rivers retreat upstream and they kind of migrate upstream in terms of their bed level. Whenever you get a nick point, it comes from the German language. And those kind of things are really encouraging to see. So we know that some of the rivers were doing okay, even back then. Pocahontas, yeah, that's right. So you're thinking, where the hell is this going? What a crazy presentation. But I always make a point of including a Disney character in every talk that I give. Obviously, in The Lion King, we learned about the importance of predator-prey relationships, the circle of life. There was Bambi, which emphasized the importance of having that kind of maternal care and the lack thereof after what happened to her and her association with a rabbit. But Pocahontas is amazing. I was born in Dartford, which isn't too far from Gravesend, where she met her untimely death. But she knew all about river restoration and geomorphology back in 1615. This isn't actually a quote from then. This is a quote from the Disney documentary. And what she said is, what I love most about rivers is you can't step in the same river twice. The water's always changing, always flowing. And that was from her paper called Just Around the River Bend. I think it was made into a song, I'm not sure. It's crazy because it comes from a kid's film. But if you take anything away from this today, take away Pocahontas, what I love most about rivers is you can't step in the same rivers twice. The water's always changing, always flowing. Okay? There's no such thing as a static river. In fact, there's no such thing as a static ecosystem. Things are always changing all around us, all of the time. And those changes are essential to biodiversity, to geodiversity, and to a natural landscape. Pocahontas knew it. Hopefully everyone in this room now knows it. So we're going to move on to some slightly academic stuff. How does geomorphology actually link to ecology? So I've written here that biodiversity is a function of geodiversity. It's pretty simple. The more different types of places there are for things to live, the more things that will live there. Fairly simple ecological concept, which I brought out in three theories. So the intermediate disturbance hypothesis, something I personally believe in and I've used in my PhD work. Simple idea. I sometimes call it the Goldilocks effect. You don't want conditions that are too hot or too cold. You want conditions that are just in the middle. And that means a moderate or a medium amount of disturbance to any system will give you the greatest diversity. Okay, some people like living in the city, some people like living out in the rural countryside, but the key point is, if you have both of those types of things there, you're going to get your maximum diversity, and it's the same for ecosystems. A moderate amount of disturbance gives you the highest species richness and also, hopefully, the highest species abundance. There's also the flood pulse concept model, which is, again, really simple. The idea is that depending on the water level within a river, as it goes up and comes down, you'll get different aquatic species, and particularly flora, establishing at different stages of that river. Okay, so you're going to get your more water-loving plants near the bed of the river, and then as you go up, you're going to get those species that don't like it so wet, so trees and such like. That's the flood pulse concept model. And then the river continuum concept. You'll notice all of these are actually quite old ideas, but they're still as applicable now as they were then. And there are lots of different bits and bobs in this. Main thing is that the species assemblage changes quite significantly as you move from upstream a river to downstream, the size of organisms change, and the type of activity that they are involved in when it comes to hunting and gathering food changes as well. So they're just 3 theories that underline a lot of the river restoration work that we do. And hopefully, for many in the room, these will be vaguely familiar. So the key thing from us when we're trying to do river restoration is understanding what the link is between what we're doing physically in there and the geomorphology and the actual biotic components. And the key link is that different landforms, so it might be a riffle, it might be a piece of wood, it might be a silt berm, will host different organisms. So what makes working in this part of the world particularly challenging? Well, we haven't got a lot of energy. Okay, our rivers are either supply limited or energy limited. For the most part, in this part of the world, it's energy. The key control upon velocity in a river is gradient, okay? We haven't got any. It's pretty flat around here, and that means that we have these energy limited systems. Some of our systems are also supply limited. The gravel's run out. We've either extracted it to put on our kind of driveways, build houses, or it's been removed in some other way. These rivers have been sitting there for 10,000 years. They've moved lots of gravel out of the system, and we haven't got any. So some of our rivers are also supply limited. And most of the rivers in Suffolk just don't have the energy to change. And that's why the River Stour looks today just like it did 200 years ago. And then when you chuck in all of the things that we've done as well, you come up against some real issues. So human-induced changes, the 2 biggest ones are in-stream structures, which are not only barriers for fish, but also barriers to sediment movement, and also excessive fine sediment input. People talk about sediment like it's a naughty word. Sediment is really important. It's essential to river functioning. What we want to get rid of is the excess sediment, the fine sediment, the stuff that comes from excessive farming or insensitive farming. Sediment itself is essential, so just something else to take away. So what do we do to deal with the lack of gradient? Well, we try to make our rivers better. And one of the things we use is large woody material. We've moved away from the term large woody debris because it's meant to be slightly pejorative. It might have negative connotations, so large woody material. This is an example from the top of the River Stour at Great Bradley. And you can see we've put in some little wooden flow deflectors, and it's had a tangible effect upon flow diversity and flow velocity. So whereas this would have been a really boring stream before with a laminar flow, no variation in water depth or water speed, you've now got something going through there which is going to provide a habitat for a host of different species. We can also narrow the channel physically by moving the banks into the river. This is an example from outside of Suffolk, but this is from the River Blackwater in Bocking. You can go down and see this. There's a footpath nearby. So all we've done is we've chucked in a bit of the artificial bank, narrowed the channel by about a half to 2/3 the width, and you can see on the right-hand side where we've kind of narrowed it down that the flow is being constricted. In addition, this shelf provides a location where different plant species can establish, get an increase in flow velocity. By reducing the embankment there, we've actually improved floodplain connectivity, which has the dual benefit of benefiting ecology, but also reducing downstream flood risk by using the floodplain for what the floodplain is for, storing floodwater. That's why it's called the floodplain. And then you've also got the retention of this deep water habitat. Sometimes river restoration schemes go a little bit over the top. Oh, we need to reintroduce the meander. We need to make sure it's all nice and shallow. Well, no. You want a diversity of different places. So in some instances, it's appropriate to retain deep water. So that's an example, from the River Blackwater in Bocking. We can also reprofile the riverbank. I haven't got any photographs of that, but effectively, again, you're creating a shallower slope so that you can provide a habitat for more plant species. Other examples of things we've done include gravel reinstatements. That can be glides and riffles, introducing gravels to rivers where they've been taken out, which is important spawning habitat for fish, and also good refuge habitat for invertebrates. And also tree planting. Tree planting is so inexpensive, but the benefits it has upon reducing water temperature, providing shelter for fish, erosion protection, creating areas within the stream that organisms can hide in within the root structure, absolutely brilliant. So I'm just going to go through a couple of examples of things we've done over the last couple of years in Suffolk. So we've got the River Waveney and Diss. All of these projects we spent about £10,000 to £15,000 on. It's not major money. It's a drop in the ocean, really. And this is an example where we actually worked with Mervyn Lambert, of all people, up on the River Waveney. Really helpful. Provided machinery and allowed us access to the site. This is advertising for Mervyn Lambert. Apologies. Other excavator companies are available. We did about 2 kilometres of a really terrible river, the top end of the River Waveney, just upstream of Diss, through a place called Bressingham. No ecology, no gradient, no nothing. It looked like this. Fairly, I mean, if you like ponds and lakes, sure, but for a river, no. And then one of my favourite Scandinavian words, a smorgasbord of techniques. We put in some wood, we did earthworks, we removed some trees because the river was overshaded, created little habitat piles. And this doesn't look like much right now, but what we've tried to do here is introduce some sinuosity, some wiggliness to the channel, which you can see from these berms, which over time will vegetate up and look good as new. And the Environment Agency kind of did most of the work, but there was lots of stakeholder engagement. We had local volunteers involved, and all of these projects are examples of partnership working, which is something we're increasingly moving towards. We've got Alan here securing one of the bits of wood using some timber screws. So incidentally, if you're thinking about using wire for securing any of these types of features, please don't. Use little timber screws, 100 mil, you can get them from Jewson's and other retailers are available. Just screw them in like that. They, once the wood degrades, they fall away and disappear and you wouldn't know they're there. Whereas big bits of wire moving down the river are not necessarily what we want to see. So that's the River Waveney. I'm going to move to a tributary of the River Stour, which is called the River Brett. Again, £15,000. We had help from Suffolk Wildlife Trust in terms of doing water vole surveys. A couple of my colleagues standing in the river there looking for water voles. About 800 metres, a kilometre. Used to be arable, but has just kind of reverted to grassland now. And we were trying to enhance what was already there, not a whole-scale restoration. You can see me there wearing a dashing white helmet, securing bits of wood in. And you can see we've used natural wood there wherever possible. The bracing pieces of wood, the horizontal pieces of wood, just make it look a little bit less artificial, though I think that one does look pretty artificial. But always think about the function the thing provides, not necessarily how it looks. That's far more important, what it does rather than how it looks. We did flow deflectors, we lowered some embankments to increase floodplain connectivity, we moved some gravel around that was already existing to create some pools and riffles, planted trees, and pushed in some berms. Here's an example of a riverbank that we pushed in, and you can probably just see at this bottom end here, there's a big bit of wood at the bottom. It protects the toe, reduces the rate of erosion, just make sure that that structure is a little bit more permanent whilst it takes time to settle in and for vegetation to grow up. Again, we had a lot of help from the Dedham Vale AOMB on this one, and Matt Holden, who's now left us. I don't know if Alex Mordeluz is in the audience, but projects officer at the Dedham Vale AOMB. And look at this happy bunch of people. Look at that. That is yeah. This guy on the far left, as you look, doesn't like being hugged. His name is Adrian, and he's one of our operatives, our field operatives, and he got quite angry after that photograph was taken. But it is all about partnership working. And I think if you're ever in doubt about the benefits of doing this kind of work, go out and do it. It is so rewarding to physically improve the environment. And that's certainly what we found as a team. And then just again on the River Stour at Langham. So this project was actually designed by the late Dr. Nigel Holmes. Very sad passing last year. We were heavily involved with him on a number of projects, and his loss really is a loss to the environmental movement as a whole, and particularly river restoration. He put together this great plan for the River Stour at Langham, about 1.2 kilometres of work there. Again, same kind of thing as before, except it's actually designated as a navigable river, this part of the River Stour, so we had to be a bit careful not to take up the whole of the channel. He put together this elaborate plan. These are just some photographs of the features that were put in and the locations where they were done. And yeah, we had to be careful about the navigation and making sure it was still navigable, the river. So yeah, just a picture of a berm, kind of gravel glide there. And again, we work with Essex and Suffolk Water, actually, Dedham Vale, A&B, and other partners. John Grant, who I think is in the audience, wrote a little piece about it, so which was again very rewarding. I'm just going to skip through this one very quickly and get to the main points. Just some more photographs, really, of the kind of things that we've been involved. Just some final thoughts. Suffolk really is a geomorphology hotspot. Never let anyone tell you anything else. Our rivers are all heavily modified, so we've got a lot of work to do. Knowing what the link is between geomorphology and ecology is essential in terms of getting our rivers up to scratch. And there are many different ways you can actually improve our rivers, as I've already discussed. It can be really simple, cheap, get volunteers involved. It can be rewarding. Contact us at the Environment Agency. I'm sure my details will be made available after this, and we will help in any way that we can. So, thank you very much.